Here is 7.4 order of operations and prime factorization. We're going to start with order of operation notes. Please remember that I will be checking these notes tomorrow, so please fill it in with what I fill in. Remember that the order of operation, it does matter what order they fall in. So parentheses, brackets, and grouping, that goes first. Exponents is next. Multiplication or division, either one. And then addition, subtraction. Remember that the reason why we're stressing multiplication, division, addition, subtraction is because those interchange. So whichever one goes first on that line, that's what you're solving first. So when you're multiplying and dividing, you're going to go left to right, and you're reading it like a book, whichever appears first. When you're subtracting or adding, you're going to read it from left to right, and you're going to read it like a book, and you're going to solve it that way, whichever appears first. So for example, which one are we going to do first? 4 times 9 divided by 2. We're going to do 4 times 9 first, which would be 36. We're going to bring down divide by 2. So our second step here would be 36 divided by 2. Don't forget that you need to solve it in like the shape of a pizza. So 36 divided by 2, the last step here would be 18. Okay. So next we have 18 divided by 3 times 4. So our first step here would be 18 divided by 3. So this was step 1. Step 2 would be dividing. So that would be 6. I'm going to bring down the times 4. And my third step would be 24. Okay. So now let's look at our first problems. Remember that the order matters. It matters. Okay, so I would always just be in the habit of writing PEMDAS. There's no parentheses, no exponents. There's no multiplication and division here. So then we're going to add or subtract. So let's look to see what we have. Okay, so we have 7 plus 5, and that's going to be 12. I'm going to bring down the minus 3, so I did my addition. Now I'm going to be subtracting. 12 minus 3 is 9. And I'm done. All right, so now let's look at number 2. Parentheses, exponents, multiplication, division, addition, subtraction. Remember, you can always pause the video and you solve it, and then you can see what I ended up with. So now I'm going to look to see what is first. 18 minus 8. So I'm subtracting first here. So then that would be 10. I'm going to bring down the plus 2. So now I'm going back to addition. And now I'm going to add. And now I'm going to have 12. And that would be my answer. Okay, so now let's look at number 3. (16) divided by 4 plus 7 times 3. I don't have any parentheses. I have no exponents. I'm going to look to see what I have first. I have division first. So I'm going to divide 16 divided by 4, which would be 4. I'm going to add everything back down. I'm not adding first. I'm going to be multiplying next. These two, which would be 21. I bring down the 4, and now I'm going to add. Okay, so here is the next one. So I have 14 plus 2 times 6 minus 3. The 6, the parentheses around 6 don't actually count for parentheses because it's only around one number. So I'm looking if there's any exponents. There's not. So is there any multiplication? Yes, there is. So 2 times 6, which is 12. I'm then going to add everything else down. So now I'm going to work right to left. I see addition next. So 4 plus 2 is 6, plus 2 more. I'm going to bring down the minus 3, so now we're subtracting. So then 26 minus 3 is 23. All right, so now let's look at number 5. Remember, if I am working too fast, you have the option of pausing and working it out and then starting in it again. So I wrote PEMDAS. I'm now looking, I have 32 minus 6 plus 15 divided by 3. So I see parentheses, so I'm going to start with that. So 32 minus 6. I'm going to regroup. So I'm left with 26. I like to leave my parentheses after I solve it in parentheses just to remember that that's what I solved. And I'm going to change that to blue. I'm going to bring everything else back down. So next, so I'm done with that. There's no exponents. I do see a division problem. So I'm going to do 15 divided by 3, which is 5. Bring down 26 plus 5. 5 plus 6 is 11, and 3. All right, so number 6, we have 5 plus 2 times 1 plus 6 to the squared minus 7. So the first thing that we need to look at is parentheses. So there's a big parentheses. So now in the parentheses, we need to look at the steps too. So in the parentheses, I see an exponent. So we're going to solve the exponent first. So 6 squared means 6 times 6, which is 36. And then I'm going to write down everything else still in the parentheses. I'm going to write down everything and then solve it now. So now in the parentheses, I see addition. So I'm going to add those. So 37 minus 7. Write everything else back down. And now I'm going to say, okay, 37 minus 7, which is 30. I leave the parentheses. And the reason why I leave the parentheses is because of problems like this. When you have like 2 times the parentheses, that means multiplication. So 2 times 30 is 60. And then I'm going to change that color back to purple. And then I'm going to bring down the plus 5. And now I'm going to add again. So your answer here is 65. So let's look at number 7. We have 18 minus 5 times 8 divided by 4 times 3. So I have parentheses. I'm going to do that first, but inside the parentheses, I do have division. So I'm going to do division inside the parentheses. 8 divided by 4 is 2. Now I'm going to do 2 times 3, which is 6. Leave the parentheses, so I had multiplication. Write down everything else. Now I have multiplication again. You can leave that sign because there's only one. So 5 times 6 is 30. So multiplication again. And now I'm going to subtract. Now, if you notice that that negative sign is with the 30, so then that means my answer is going to be negative. So I'm just going to subtract normal. And I know that it's going to be a negative. So that's going to be a negative 12. That is something that you have to pay attention to. All right, so then the next one, I have 9 plus 15 minus 8 plus 3 squared divided by 2. So I do have a parentheses. I'm going to solve everything, and then I'm going to square it. So I'm going to go left to right here. So I have subtraction. So 15 minus 8. 8 plus 2 is 10 plus 5 is 8 plus 2 plus 5 is 7 plus 3 squared divided by 2, 9 plus. So now I'm going to add those two. Keep the squared. So now I'm going to look at my exponent. So 10 squared is 10 times 10, which is 100. Then you're going to have to divide, which is 50. 100 divided by 2. And then I'm going to bring down the 9 plus. I'm going to add those, and I'm going to get 59. Okay. So there is that. Remember, you can always back it up and rewatch anything that you need to see. So let's look at prime factorization now. Factors are whole numbers. We can multiply together to get another number. So that's like 3 times 3 is 9. The factors of 9 are 3 and 3 and 1 and 9. Prime numbers is a whole number. And itself to divide. So prime number is a whole number, blank then 1, that cannot be made by simplifying. Hold on one second. I want to make sure I write down the correct definition, and I have the page right here. I feel like it's just like class. Sorry. It is that of itself is multiplication. I do not know where I put that paper. There it is. Okay, sorry. The whole number greater than 1 that cannot be made by multiplying other whole numbers. It is only positive factors are 1 and itself. Composite numbers is a whole number that can be made by multiplying other whole numbers or factors. When we have prime factorization is when you break a number down to its prime factors. And that's why we use a factor tree, because those are diagrams used for branches to find the numbers of prime factors. Each branch ends at prime numbers. It is common to write the prime factors in ascending order from smallest to largest. Okay, so if I look over here and I have 24, I have 4 and 6, but then I have 2, 2, 3, and 3, which means that I could do 2, 2, 3, and 3 in expanded form, and then it could also be used as exponents, which would be 2 squared times 3 squared. So let's try those. So I have 12, which means prime factorization would be 2 and 6. 2 is done. 6 would then be 2 and 3, which means I have, how many 2's do I have? I have 2 2's and 1 3. 42, if I divide that, I could have, if I wanted a prime number, I would use 2 and 21. 2 is prime. Now I'm going to find the factors of 21, which would be 7 and 3, and both of those are prime. When I write that out in expanded form or exponents, that would still be 2, 3, and 7. 50 would be 2, and then what times 2 is 50, which would be 25, and then the factors of 25 would be 5 and 5, and both of those are prime. So then I would have 2 times 5 squared. For 100, I could multiply that. I could divide that and get 10 and 10. Now there's other factors there too, but 10 and 10 work. The factors of 10 are 2 and 5. Both of those are prime. And then I have 2 and 5. Both of those are prime. I have 2 2's, which would be squared, and 5 squared would be for that one. And then the last one, I have 40, which would be 4 and 10. Simplify 4, I could break it up by 2 and 2. Both of those are prime. And then 2 and 5. Both of those are prime, which means I have 2 to the third power and 1 and 5 to the first power. All right, you need to make sure that you copy that down. If you have any questions, please let me know, and then you can start on your assignments. Please be good. Have a great day.